This webcast discusses the conclusions of the gravitational force lab. So remember, the purpose of this lab was to determine how the gravitational force between two objects changes as the masses of either of the objects or the distance between them are changed. Because there were three variables that could be changed, we had to complete 3 different experiments in order to conduct a controlled experiment. And I'll just, as an example, show you how to put in the information that summarizes each experiment. So first I'm just going to show my experiment 1 because yours will be different, right? But in my experiment 1, my mass 2 was held at 303 kilograms and the distance was 6.6. And so I'll say the mass of object 1 was varied from 10 kilograms to 1,000 kilograms. I'm sorry, 1,000 kilograms, but the mass of object 2 was held constant at 303 kilograms, and the distance between the two objects was held constant at 6.6 meters. Now remember, your constants should be different than mine, but I'm just recording what mine were. The graph had a shape that was linear. And so I would write my physics equation here. The gravitational force, and I'd have to go back, I guess, and find that physics equation, but here I can go. My slope was 4.642 e to the negative 10th. You know, we're just copying this from up above where it was created, and the units here were newtons per kilogram times mass 1. It's very important to be clear which mass was used as the independent variable in your physics equation, okay? And this slope means that for every additional 1 kilogram of mass added to object 1, the gravitational force increased by that 4.642 e to the negative 10th newtons. Okay, so you would do a similar summary for each one of the 3 experiments. Then we have something that starts in summary. Okay, so I'm over here where it says in summary. And these 3 experiments demonstrate that gravitational force is proportional to both mass 1 and mass 2. That's because we got linear graphs for both experiments 1 and experiment 2. But the gravitational force is proportional to the inverse square of the distance. Remember, we had to take the inverse square of distance in order to get a linear graph. And so if we wrote a consolidated equation, kind of a merged equation, we would have that the gravitational force equals some constant times mass 1 times mass 2 and divided by that distance squared. So here I'm using k just to represent some constant of proportionality, some slope. The slope will be different now that I'm trying to merge my 3 physics equations, but I'm keeping the same types of relationship between the gravitational force and each of those variables. Okay, we need to go find this value of k. And so we're going to go back, and for each experiment, we're going to solve for what that k is. So I'm going to begin by writing, my process is to write the merged equation. Okay, so I know that the force of gravity equals that constant k times mass 1 times mass 2 divided by r squared. Then I'm going to write the physics equation for experiment 1. And so in experiment 1, I found that the force of gravity equals, I'm sorry, I'm going to have to go back and look at my slope again, 4.642 times 10 to the negative 10th. So 4.642 times 10 to the negative 10th times mass 1. Both of these things are telling me what Fg equals, the gravitational force equals. Therefore, they have to be equal to each other. So I'm going to, set them equal to each other. And so I've got that 4.642 times 10 to the negative 10th times mass 1 equals K times mass 1 times mass 2 divided by r squared. If I divide both sides of this equation by mass 1 cancels out. I had it on both sides of the equation, and so I can just cancel it out. And I'm trying to solve for this value K. Right? This is what I'm solving for. And so all of these things that are multiplied by K, I'm going to move to the other side. Okay, so that means that 4.642 10 to the negative 10th times r squared and divided by mass 2 is going to equal K, right? Then I'm going to plug in the values that were held constant in experiment 1. And in my experiment 1, the distance between the two objects was 6.6 meters, and that r has to be squared, and mass 2 was held at, why can't I remember? Let's see, mass 2 was held at 303 kilograms. Okay, and so I can solve for K. Let me just do that math, and I'm going to have what K equals. So I've got 642 times 10 to the negative 10th. I'm multiplying by 6.6 squared, and I'm dividing by 303. And I get 6.673 times 10 to the negative 11th. Right now, don't worry about the units, but let's find the value of K. I have a good value of K here because that's what we're looking for. We know that K does equal 6.673 times 10 to the negative 11th. You need to do this for each experiment. It is the same type of process where you start with the merged equation, then you write the physics equation for that experiment, whether it's 1, 2, or 3. You set the two equations equal to each other and solve for K. Then you plug in the values that are held constant during that experiment. If you get a number that is different than this, 6 point anything times 10 to the negative 11th is okay. But if you were to get, 4 times 10 to the negative 11th, that's not correct. If you were to get something times 10 to the negative 7th, that's not correct. It has to be very close to this number. The simulation should give us, very exact results. And so if you get something that's different than this value, that means that either you've made a mistake in your calculation, and that would be the first thing I would check. Make sure that you did this math correctly. Or if you were doing the math correctly and you still got a value that's different than this, you made a mistake in taking the data as you were recording data for the experiment, and you will have to go back for that experiment and redo it. Go get data, making sure most likely you wrote down a wrong value of one of your constants. Perhaps in the simulation you had a value of the distance that was different than what you wrote down, for example. Okay. And then once we have found that all three experiments give us this same, value of K, then we will say that the value of K was found to be 6.673 times 10 to the negative 11th. And and we're going to get the units for that by dimensional analysis. In order to have our merged equation have newtons on both sides, then this constant K, which now we're going to call the universal gravitational constant, which is called G, it has to have units of Newton times meter squared divided by kilogram squared. Okay, we're just going to rewrite that merged equation. Gravitational force equals G, this universal gravitational constant, times mass 1 times mass 2 divided by the distance squared, where G is the universal gravitational constant. It's 6.73 times 10 to the negative 11th Newton times meter squared divided by kilogram squared. Okay.